I can see a couple of thumbs ups, a few more as well. That is perfect. Welcome, everyone. Okay, so like we said, we have a little bit more to go on, and then we'll go for lunch and lab in that respect. But we need to go through some of the networking aspects and edge related elements first in order to do so. We have a question as well in chat. Jacek saying another question. What is the benefit of having SQS SNS over having direct trigger to S3 event? It's because, Jacek, an event notification here, again, will not retain those messages. So if there's any sort of issue here, or a overload of event notifications, but not enough capacity to process, then we would lose messages and not have the ability to process them in due course. With SQS, we give ourselves time to process those messages. Does that make sense, Jacek?
Yeah. So the benefit is we cannot see benefit now because we have only 3 images, but if we have like thousands per minute or something like that, then it will be benefit. Okay, yeah.
Absolutely, exactly right. With 1 or 2 message testing, it's not straight away obvious, but with thousands or tens of thousands of messages, yes, absolutely, that would be way more apparent.
Okay, thank you.
No problem at all. Also, longer processing times. What if Lambda takes a minute per message, for example? Then, of course, even at 10 messages, we'd see that benefit. Not to mention, we can react based on message and queue length. So a metric can be used as a queue depth, so amount of messages in a queue, and that can be used for scaling purposes.
Yeah. Then, because one Lambda can receive only 1 message. So if there is many images, then there is no possibility to queuing without this construct. Yeah, that's clear now. Yeah.
Absolutely. I will just adjust one aspect there. Lambda doesn't just see 1 message, actually. It could see 1 or more. So it could see batches of messages also. So that's also possible. But that's way too advanced for our moment in time. Pavdeep, cost-wise, using SQS and SNS with S3, which would be beneficial if there are maybe 5-10 messages a day? Maybe 5-10 messages might not warrant this whole architecture here. Maybe just S3 event notification to Lambda directly, since it's only just a handful of messages. But really, the best thing to do with any cost-related question is just to go to pricing calculator and work out the cost as well, because then we can adjust it. We can say 5 to 10 or 5,000 messages as well. So pricing calculator, Bhavdeep, really useful on this as well. So there we are. We can configure SQS to see how many messages in FIFO way or standard, how many as well. But as you can see here, it does calculate per million per month. So at 5 to 10 messages, it's going to barely cost anything.
Yeah. Okay. Yeah, because I came to this approach, but I was just trying to plan with only SQS, not use SNS in between that. So that's why I was thinking and since there are chances, if there are failures, then there are chances that if there are any bad messages residing between the queue, there are chances that I have to restart, or maybe I have to take those messages out of the queue so that the Lambda can process the rest of the message. So there were quite a few things which was needed to be taken into consideration with this approach. So that's why I thought with S3, at least I can have those messages residing with me, and there is very less chance of missing any messages if in further I need to go back and look into it.
Absolutely. But I would say for a messaging purpose, and might as well, this will take us into completing this module here. Actually, another message handling service is going to be in Kinesis. So with Kinesis, we have multiple options here. We have Kinesis data streams and Kinesis firehose. Technically a couple more, but we don't go into these here. Kinesis data streams is another messaging system, but this one works a little bit differently versus SQS in the following sense. You still have to read from the stream, but you need to install or specify the Kinesis consumer library, so it's a more specialized approach here. And whereas in SQS you have a 14 days retention period as a maximum, in Kinesis you have 365 days as a maximum. Also, the messages actually stay for the duration that you put them in. Take SQS, for example. A consumer reads the message, polls the message, and then deletes the message from the queue upon successful processing. Meaning another consumer can't read it. That is why it's a one-to-one with SQS. Well, with Kinesis data streams, you can have messages and they will stay for the whole duration of your retention period, be it 1 day or anything up to 365 days, and you can process them once on day 1 and then again on day 50 if you want to. So the messages don't go away when you process them, you can process them multiple times. So if you remember Bhavdeep, when we talked about your architecture yesterday, we recommended one of the solutions was DynamoDB streams and or Kinesis data streams. So something to look into as well.
Yep.
But then we also have Kinesis data firehose. So how does this differ from data streams? Well, this one only has a 24 hours retention period, so smaller. It's simpler, so you don't have to actually have a consumer. We technically send the data straight into storage, and technically it goes to S3 first, then into Redshift or other elements, but that's a more technical detail there. However, Kinesis data firehose can do this. So we can have Kinesis data firehose. There we go. And as messages get placed on data firehose, it can take some of those messages and essentially put them together, batch them, as well as compress them. So it will take them and make them smaller, compress them. So ultimately, over a network transmission, it's going to be a more efficient transmission of data into the storage solution. So batch and compress are additional capabilities here with data firehose. And both can be used together, so you can have Kinesis data streams sending data to Kinesis data firehose, technically a stream to a consumer, and this puts it in data firehose, and then through batch and processing, we go to a storage solution. There are quite a few different architectures capable here. But we're just showing the highlights so you know what you can go and inspect in further detail or what you can ask me to converse on separately during the lab time in more detail as well. Ultimately, they're just one slide mentions here in architecting, really just highlights, if you will. From a different perspective, if we shift away from our messaging tools and we talk about entry point into our solutions, we have API Gateway as a way to publish, manage, handle, and secure our APIs. It can process thousands of concurrent API calls from third-party solutions, public ones as well, and it can integrate with almost anything API related, AWS services, or even third-party endpoints, be them on other cloud vendors as providers and any other endpoint, or on premises through private connections that we'll inspect shortly. So it is very flexible, ultimately. Now, we could look at the features through the slides, but otherwise, I'm going to show them to you in the console better. So let's bring the console here, and let's have a look at APIs. We can design APIs in different types. We can design more clever REST APIs or simpler, more performant HTTP APIs, or stateful APIs that persist a connection between the client and the backend integration. We can even choose private APIs. Normally, we use them as public to get public-facing endpoints issuing a request to our API endpoint. And we can even, whilst it's a regional service normally, as you can see here by the region name, technically you could put it on the edge locations network, really getting your API endpoint closer to end customers from a latency perspective. You can even import it from third-party API solutions such as Swagger or OpenAPI, so it's quite manageable in various ways. And once you create one, you can handle quite a few things with it. So I have a few demo APIs here that I will show you, just to show you a few features. We define various resources and methods to which we access those API resources. And notice this, if I issue a GET request to the API endpoint, which is going to be part of stages here shortly, that request gets authorized if I wanted to. I could just simply remove the authorizer and then any request goes through, or I say only if it's allowed by the authorizer. Then, if it's allowed, it goes through to a Lambda function or other integrations, third-party AWS services, or just testing purposes with mock. And then the Lambda function triggers and the workflow proceeds. There we are. Let me show you another API here, where if I test this one, let's say I am placing here a book. This is the payload that I'll send. Well, actually, I need to put it on the post request. Give me a book, everyone. Give me a book name. Let's not use my default. Let's use something personal here. Personal as in personalized to the course, if you will. Any book name that you want. We have a private message saying 1984. I heard it's a good book. Do you know the author as well, by any chance? Orwell. There we are. Let's test this. I have sent this payload. It is a success response, and there is a serverless architecture that does this behind the scenes for me. I've run out of digital paper here. Actually, I have some at the bottom. What happens there is my API gateway receives the payload, the message with the author and the book, which triggers a Lambda function to fetch an object from an S3 bucket. It takes this object, adds the detail, well, replaces the details with a message from the JSON payload here in the object, and then puts the object back with the updated data in S3. On the put request here, we have an event notification, which triggers another Lambda function to send me an SNS topic-based email to my personal address. We won't explore this in detail here unless you want to separately during the lab time. But now there we are. As we were talking, this is the email that generated a link to download the book. Now, unfortunately, in my corporate email, that gets a little bit badly formatted, so I'll show it to you in my personal email here. There we go. So this is the link, the URL, and if I click on this one, I received that book. So you can see over here, Orwell 1984. A bit of messy format here, but that's because I need to produce a better formatting solution of the Lambda function. That's a little bit beyond the point here. The idea is, think of this as a book publishing website, or maybe it's a sales solution. You want to publish sales on the Sainsbury's website, or you want to send some vouchers as well with more personalized solutions. So, for example, instead of author and book, you have customer name and email. You feed that in to your solution, and then it dispatches various promotions based on what the customer did. So just an example, everyone, of how we can use these serverless solutions. I'm more than happy to show you this in a lot more detail, but it is beyond the point to do it live. It will take us too far away from the course, if you will, but it is a very interesting aspect that we can dive into further. And the API gateway and the other tools on the screen help us with that. And I've done all of that myself by setting up all those services individually. And I can't see them all in one place because I don't have an orchestrator. But with step functions, we could do that. Think of step functions as a way to coordinate multiple microservices using visual workflows. Essentially, it gives you the ability to perform like a vending machine type of logic. You submit an input, and based on that input, we check, is it valid, or we're waiting for something, a transaction, a selection, and then a result. And it does actually look pretty much like this because it is a visual workflow. It does show you how you tie your Lambda functions one after the other, whether you're writing to DynamoDB, whether it's a success or failure as well. You can implement waiters, error handling, choice states, and more. And let's have a brief look at this as well. There we are, step functions here. And that's right, Nikos. We will address that question in a second. So I already have a state machine here, or step functions resource. And if I execute it, notice what it does. It's actually showing me how the process flows. It's basically checking the value of stock price, and whether it's bigger or smaller than the value of 50 is going to tell me buy or sell. These are Lambda functions tied together to provide that input, that logic. And notice here at the buy or sell, it saw the value is 54, so a little bit bigger. So it says sell because we're going to make a profit. So it goes around the choice state of sell, which is a Lambda function that will issue the sell command. Now, this really is a series of services, could even be EC2s added here if we wanted to, or even creating organizations, units as well. And we can even work with it in code. So, of course, there is a code definition behind the scenes that dictates what Lambda function calls which, but the visual workflow is also really, really helpful. So there we go. If I want to say launch an instance when we buy stock, I can do that. And I can put it as a parallel action as well if I want to. So let's go here, low, parallel. I'm going to drag this here and this one here, for example. And this I would have to report the result afterwards as well, after that action. So we can work with this in various ways. It's a really useful tool. All right, everyone. Before I get to ask if there are any more questions, we do have one from Nikos here. Is it useful to attach SNS or SQS to API gateway? Is it a best practice and when? Nikos, yes, you would be able to, and it's really just the best practice is based on what you're trying to achieve, based on the features of the services. Do you need to quickly send messages to multiple endpoints? The same message to multiple endpoints, then SNS. Do you need to put messages in a queue because you have a large processing, not so large processing unit downstream, so it needs to wait to have time for those messages? Then SQS. That's really how we should use it, Nikos. Quite simply, think of your downstream processing service. Will it have time to process the messages every time? SNS. Will it not have time? Then you need a buffer, an SQS, a Kinesis data stream as well. So those kind of solutions. I should say though, API gateway SNS Lambda, we might not even need SNS because it's not doing anything here apart from just adding an extra step. Unless it's actually shooting off messages in all directions, we could just put Lambda straight away here. Does that make sense, Nikos? So is that all right? Is that, yeah, that is perfect. No problem at all. All right, everyone. Oops. Any final questions here before we go and have a look at networking, additional concepts? If no further questions, do let me know, please, with a thumbs up or a +1 in chat. Again, I am mindful we are going at a brisk pace. We are not rushing through the content, but it is an alert pace, if you will, simply because there's just a lot of content to cover. So if you want to explore anything in a lot more depth, do let me know, please. But just remember, it's a lot of information at high level, so that's why we keep it somewhat high level. Any depth during the lab time, I'm more than happy to give you a lot more insight as well. The next module with networking, again, really just mentions here. Okay, that's, yeah, really PowerPoint is playing some tricks on me today. There we go. So with networking, everyone, we talked about VPCs. The question here is, what if there are more? So as far as you are aware, or do you use more VPCs yourselves? More than one? Okay, highly likely, incredibly likely, more than one, as we can see here. So we're going to help our network engineer with solving a few problems by giving these kind of solutions. VPC additional elements by privately routing traffic between VPCs or VPCs and other elements. Basically, the theme here will be privacy. This is a very visual module, so we're going to whiteboard this one as well. The slides will tell us the exact same story, but we are building. It live here, if you will. There we are. Okay. So for the person that's messaging me privately, my apologies. I was under the impression it will be a little bit later, but absolutely. Feel free to message me as well. Absolutely. All right. So let's talk about privacy here. Let's have ourselves a very simple VPC with an EC2 as well. There we go. And let's give ourselves an EC2. This right here is a virtual private cloud, much simpler than how we've been drawing it so far, because we need to illustrate other concepts. We have an S3 bucket. Can the EC2 talk to S3 now? What do we think? Nope, not yet. Assuming the route tables and everything is there, what about now? Technically, from a networking perspective, yes, now it's possible. We can issue those API calls. Now, whether or not we can get the objects from a bucket, that's a permission aspect. But from a networking perspective, yes, we can. But like we said, the theme in this module is privacy. So we want to avoid the internet. And that applies to other services as well, such as DynamoDB, Systems Manager, Lambda, API, Gateway, config, and more as well. All of these are non-VPC resources, but we may need our resources inside to talk to them. So what we will use here for private connection between VPC and non-VPC resources in this region is going to be VPC endpoints. VPC endpoints come in two ways. Gateway endpoints, which really only work, they are the easiest to remember because they work only with DynamoDB and S3, just with these two services. They are a gateway solution here, VPC gateway endpoint, and you would have to specify one endpoint for each. All the other services, and there are a lot, so documentation will show you tens of services. Those are interactable with interface endpoints. So that will be all of these services and more, including S3. S3 is the only service that works in both ways. Interface endpoints are provisioned in a subnet. So unlike gateway endpoints, they are provisioned within a subnet. And from there, we connect technically to the prefix list of the service that we are trying to access privately as such, for example. Nice and simple, really. There are further intricacies here. For example, VPC interface endpoints cost, while gateway endpoints do not. You can put security groups on interface endpoints and resource-based policies on both. But like we said, we are keeping things simple here, and your slides will show the same aspects. A few more technical details as well, such as the fact that interface endpoints are powered by private link. This is basically the name of the technology powering that solution. And you have a few diagrams as well in the slides to show those aspects also. So just like we said, gateway endpoints and also interface endpoints as well at a subnet level. Do remember that talking about networking means, depending on the endpoint, we have to configure routing as well. Now, we've solved VPC to non-VPC connectivity. What about VPC to VPC? Can these two EC2s talk to each other? And yes, Jacek, VPC endpoints will take IPs, addresses from the subnet that they're provisioned in. Absolutely. So everyone, if routing is defined correctly in my diagram, will these VPCs, EC2s, be able to talk to each other? So we have internet. Is anything stopping them if we have open security groups, route tables, and everything? They could communicate. We don't want that. We want private connectivity here. So for that, from the internet, absolutely. Nikos, from the internet, they can. Like this, they absolutely can. If the internet connectivity is configured. So route tables route to the internet 0.0.0.0.0.0/0, and then they will be able to. But like we said, privacy is important in this module. So first, we need to ensure these VPCs have different CIDR ranges. That's quite important for the next discussion because, quite simply, they will need to communicate. And much like you can't call your own phone number, neither private networks, neither IP addresses can't call themselves. So we're going to have VPC 1 and 2. And if this is satisfied, a VPC peering connection can be established. And now, if we also define the route tables to point to the peering connection, this EC2 can use its private IPs to talk to this EC2 here, completely private across AWS's network. Right. So we might need another VPC. There's no gateway per se. It's a VPC and it's a VPC peering connection, which will be referred into the route table as well afterwards. So this is what it would look like. It's basically just a network connection to facilitate traffic to go into another VPC, but everything is private as well. If I show you in the console as well, Jacek, I do actually have a peering connection established. I should have it in this account. So if we check here, first of all, let me show you the there we go, peering connections. I have a few here established. Let's say my new peering connection, for example. If you see here, requester VPC, acceptor VPC. And you can see I have technically multiple CIDR ranges, but the point is none of these overlaps with the acceptor, different CIDR ranges. And in terms of the routing, let's go to one VPC here. if I check the route tables for this one, notice what it's pointing to. If I want to talk to the VPC with this size range, Jacek, I am pointing to a PCX peering connection. That's how we abbreviate it. Does that make sense, Jacek?
Yeah, thank you. Thank you.
No problem at all. And we can, of course, peer another VPC. We can add another VPC here, like this. And I could add another one as well if I wanted to. But the thing is, if I do this VPC peering connection to VPC 3, one cannot talk to 3. It can't use an intermediate VPC as a jump box or a jump VPC. It doesn't work. That would be transitive peering and it's not supported. So what we'd have to do is establish another VPC peering connection. And whilst this is supported across regions, I'm sure you can already see a potential issue. So let's say, even though we have this across regions, let's add a few more VPCs. Now, in order to have a full mesh connectivity here, I have to make this connection, this connection, this one, this one, this one, this one, this one. Am I missing anything? I think this one. It gets complex. It doesn't scale well. It's cheaper to implement than in next counterpart, but it's tough to manage, and it has maximum limitations as well. We can only get up to technically 125 VPCs as well, 125 connections. We can dive deeper if we need to, but the idea is it's complicated to scale. So instead, we'll do something else here. We'll have this VPC, another one, another one, another one as well. There we go. Let's give them side ranges also. And we will add the numbers 1, 2, 3, 4. And we can get all of these to talk to each other by putting a transit gateway in the middle. This will create something called attachments to the networks of those VPCs, more specifically per subnet, and it's going to be much easier to handle as a central solution here. We didn't address this, but we've shown when we went into the console that I have to update route tables. With VPC peering, I have to update every single VPC's route table as I work with it. That's a lot. With Transit Gateway, I only manage the route table on the Transit Gateway if I want to. I can have the flexibility to dive into the others, but I don't have to. I can keep it simple, and I can say VPC here, 2, 3, 4. I can say 1, 1, 2, 3, 4. And quite simply, if I add another VPC, all I do is say, yep, put this in the route table as well, create the attachment, and now every VPC can talk to every VPC if they want to. It's what we call a hub and spoke model, and it can scale much better up to 5,000 connections. So it can go much bigger, but it does cost. So Transit Gateway isn't free. It's still about private connectivity here. So we're still not using the internet at this point. So does this make sense so far, everyone, with these two alternatives for VPC to VPC connectivity? At a high level, of course. That is perfect. Before we move further, let me just say that in the slides, we answer the question, well, what if I don't want everything to talk to each other? Normally, at these sized networks, we have more complex topologies. A private VPC, a shared services VPC, maybe one of these VPCs has an internet gateway, and we use that as the only internet-based access. We have some topology examples in the slides as well, where we talk about full connectivity. Everything talks to everything. Or just two VPCs, one with each other through the transit gateway, and like this. Or none of them talk to each other, but they all talk to an on-premise solution. So in the slides, you have a few further examples as well. And that takes us nicely to the fact that Transit Gateway can connect to on-premises via either a direct connect connection or a VPN connection. Both of them are possible to connect to an on-premise environment. So this is taking things to a hybrid level. So let's explore these two now separately, because we could connect them to Transit Gateway or we could connect them to VPCs. That part is a little bit less relevant. So everyone, we have an on-premise solution here, and we have AWS here with, I'm going to take this VPC. A very quick to implement solution using the internet as the underlying hardware to connect on-premise servers to our AWS solution would be by issuing a customer gateway on-premise and connecting it to a virtual private gateway on AWS, and this would be an AWS site-to-site VPN tunnel. It is built across the internet, but the benefit is you have IPsec encryption for your tunnel here. So benefits, it's encrypted, more secure traffic, but drawbacks, well, you're still using the internet. So really, you have a maximum up to 1.25 gigabits per second speed. And it's fluctuating because it's the internet, isn't it? Whereas alternatively, you can take advantage of things called DX locations. This is not an AWS building, but rather a telecommunication provider building that is physically connected to AWS, as we can see here. Now, we don't know where this is, we don't know how that is, we don't need to. All we know is if I want to have a physical cable into AWS, I can go and also get a cage, a router, a customer router in that location. And then I can ring up AWS and I can say, hey, AWS, can you give me a connection between my router and yours? All physical, all the way from this side to this side. And once that is established, that's what we call Direct Connect is a full fiber linked cable that is capable in the most performant option with 200 gigabits per second. This is basically two pipes of 100 gig per second. And that is the speed. It is yours in full. You do not share it with anyone unless you want to, of course, but it's your choice. But it is physical. This is not going to take minutes. This is going to take days to months to implement. Because we're literally talking about installing a physical cable from an AWS Direct Connect location into your data center. And I want to show you one of these Direct Connect locations because, of course, to connect one, you need to know where they are. And one in London is actually really, really cool. So there we are, different addresses, different locations, including this one at the London Docks. If we check this one here, you can't tell it's not an IT. You can tell it's an IT building because it's a very, very IT building architecture there. It has a big on and off button here. So how much more IT building does it get than having an IT button on the side of the building? I think that's pretty cool. I think that's pretty fun architecture right there. But on a technical level, everyone.
So is that for if that was the UK, is that not a single point of failure? If that building was no longer there, everyone would lose connection to AWS.
That is a very good point, Andrew. And absolutely, you're absolutely right. As high availability, recommendations for best practices are these. So AWS Direct Connect high availability is to basically use multiple DX locations, multiple pipes, and ideally you would have at least 2 data centers as well. This is a more resilient architecture here. So you're absolutely right with that statement. But going deeper, we would be exploring these if we went to that level of detail.
Okay, thanks.
Does that make sense?
Yeah.
That is perfect. And technically, Andrew, this is how we can also, technically that's how we can get more speed as well by aggregating in a link aggregation group. There we go, 2 different lags per DX location, and the maximum speed is 2 100 gig pipes. So everyone, yes, please.
Oh, I was just saying thank you.
No problem at all. So everyone, like we said, you have this information in the slides as well, site-to-site VPN and Direct Connect as well, with a few more technical jargon as well for exact technical differences as well, but we did explore the more important aspects. Like I said, I don't want to just to brain dump information. Any questions on anything we looked at here before we have a presentation of CloudFront as part of the Edge services, so we can also approach the lab. I am mindful we need to go for lunch and lab, so we will complete the Edge services module after lunch, but I just want to give you the information you need to do the lab, and that is about CloudFront. So any questions here, or are we quite all right? Remember, they are high-level presentations on these modules. Technically, I've presented solutions where we've talked for 2 days on Direct Connect, VPN, and Transit Gateway and the like. So it can go into a lot more depth. If you want to, during lab time, I'm happy to show you. Okay, thumbs up all around. So let's not waste any time here and say that we will talk about the Edge about Row 53 as well after lunch and lab. But in the meantime, let's reiterate CloudFront because, like we mentioned on day one, sometimes we do some leaps into the future in this course, and CloudFront was one of them. So we have introduced CloudFront as a content delivery network living at those edge locations that we talked about in our first day. More than actually 500 plus edge locations now, it might be even 550 actually, if I recall correctly as per the latest update, but there are more. And CloudFront distributes content to the edge, as we've seen in day one. It takes content from the region. So if we have a region here, there we go, I have an object or a file, and then it delivers it through to the edge locations for quicker access from those points of presence. It doesn't necessarily cache it. That's our choice. Because what if it's dynamic content? This should not be cached. This should have time to live equal 0. But if it's static, TTL, it's up to us. You could be it could even be 1 year worth of caching or more. Default is 24 hours. So it's up to us how we define that. We talked about caching as well, and we've explained this in day one as well. So this is more of a reinforcement, if you will. CloudFront is the service that can cache if you need to at those edge locations. And it can get data from load balancers and ultimately from EC2s, S3, and this is what you will be doing in a lab shortly, or even custom origins. Ultimately, it's a request to an HTTP endpoint. And the benefits are like we talked about in the caching solution as well. When a client makes a request to the caching layer, in our case, the edge location handled by CloudFront, we can respond with the data straight away, or if it's not there, CloudFront can go to the origin, fetch the data, and then respond to the customer. But it is CloudFront that does that. If the customer wants to access the origin, it won't be able to. You will control this in the lab via installing an origin access identity. That's going to be part of the lab for you to configure along the origin, which will be S3 in your case, as well as creating a distribution. This is basically CloudFront configuration here. This is where you define where you cache, how long for, who is able to access, over what path, the time to live. Do you provide more security features such as different hash keys or signed URLs as well? You can really configure this in a lot of depth. You can have HTTP, HTTPS. You can enforce HTTPS or not, or you can perform redirects. Again, quite a flexible solution. You could even geo-restrict countries as well if you want to in CloudFront. And optionally associate security solutions such as WAF, Web Application Firewall, something that we will explore as part of the after lunch and lab session. So everyone, CloudFront, fairly simple and high level as well, based on everything that we talked about so far, especially. And you will build it as part of lab number 6, because you will configure a CloudFront distribution to distribute your content from your solution in S3 much quicker. So any questions here before we go for lunch and lab? Or do we have +1 and thumbs up, everyone? I can see a few, but just making sure. That is perfect. All right, everyone. If you want to explore anything in more depth, do let me know. But otherwise, I will put a timer on the screen for lunch and lab here. Let's say 1 hour and 40 minutes as well. That should give us enough time here to do the lab, have some lunch as well, and also have some time for further discussions if we want to. Actually, got an email, but only for day 2. Okay, that's all right. I will resend email number 1. Hopefully that will reach everyone. So I will double check that to make sure everything is being sent appropriately. All right, everyone. So enjoy lunch as well. Enjoy lab. My apologies if we went for lunch a little bit later today. We did mention it's a bit of a different day, shorter teaching, but a lot of labs as well. We technically have another third one that we'll do around 3:30 or so. So lunch and lab, everyone. Enjoy your lunch. Enjoy the labs. And if you need any help, I'm here all the way throughout the next 1.5 hours. Enjoy, everyone. I will see you shortly.